All right, everybody, welcome back to the Python WebConf Track 3, the Cloud track. My name is Josh Qualls, the LoudSwarm account manager here at 6 Feet Up. I'm joined by Sohan to talk about building cloud infrastructure using Python.
First of all, thank you so much, Josh, for having me. And yeah, thanks everyone for attending. So let me introduce myself. My name is Sohan Maheshwar. I'm a dev advocate with AWS based out of the Netherlands, but today I'm coming to you from Bangalore, India. So today I'm going to talk to you about building cloud infrastructure on AWS using Python. And I'm going to talk to you about this via something called infrastructure as code. Now, this is typically a talk for people who aren't too familiar with the cloud or maybe know the cloud, but aren't familiar with the concept of infrastructure as code. So if you're an expert, you might know some of these things, but it's always good to refresh your memories. So today we are going to be talking about what really is this infrastructure as code, or what is infrastructure is code. We will talk a little bit about this platform called AWS Cloud Development Kit, and we will be using that to really build cloud infrastructure. I will talk about the technical details about how it really works and how it simplifies your life when you're building cloud infrastructure. And of course, I will show you a demo. So let's get straight to it. So a couple of years ago, our CTO, Dr. Fenner Fogels at reInvent, he basically made this very bold claim. And what he said was this. So what does the future look like? All the code you ever write is business logic. Now, a few of y'all might be full stack engineers, a few of y'all might have dabbled in the cloud, but you will know, even if you're part of a startup or an enterprise, that nowadays writing code is just not only about writing business logic. You invariably have to do things like set up unit tests. You need to make sure you can scale. You need to make sure security. You need to make sure about distributability. So all of these things are part and parcel of your job. But in the future, we really envision this future where you as a business can only focus on writing your business logic, and that is your code product, which helps your customers. But to get there, though, we're going to still take some time, and there are a lot of missing pieces, and infrastructure as code is one of them. If you really look at modern cloud applications, they all have a lot of bits. Gone are the days when we had monolithic applications, like this one giant application with all your code written in, with your database, with your views, with literally everything. And one small change, like even, maybe making a typo would have like the 6-month release life cycle. Those days are gone. If you take something like, say, an Instagram, for instance, it's built in a very modern fashion where your database is its own service. Your cloud distribution is its own service. There's auto scaling, there's load balancing, there's data analytics. And all of these are what we call microservices, which sort of talk to each other. So it is fairly complex that way, in the sense that they're all separate from each other, which are all talking to each other. And this enables really rapid iteration. If you want to push an update, you can do that very easily with this sort of architecture. To do that, though, we have to talk a little bit about how cloud infrastructure is actually built. And that's what I'll talk to you about right now. I'm going to assume that you have a fair idea of what the cloud is, about how you can deploy hundreds of servers in the cloud to serve your customers. Now, if you have to do that, the absolute easiest way, or the first thing you would do if you're a beginner, is actually create this infrastructure by hand. So we have Alice and Bob here, and what they would do is they would actually click on the create EC2 instance or create server button. They'd give a bunch of configurations and they'd hit start server. And if you're creating 10 servers, you'd do that 10 times. But if you're creating 100 servers, you would actually do it by hand 10 times. Now that's good. I started my cloud journey doing that. That's a great way to learn. But when you're actually building large applications or large businesses, this doesn't really scale. There are many reasons why it doesn't scale. One is, of course, it's manual. You can't pass on information. Say Alice or Bob leaves the company, and then you're like, both Alice and Bob have left. How do they actually do this? Maybe let me just look at like some documentation and copy paste everything they did. Second is it's really time consuming. There's no way to like scale this in a process point of view. You're actually writing all these settings every single time. Also, it's hard to audit if there is some error somewhere. And let's face it, this method is prone to error. How do you really go back and say why that error happened and when it happened? Because all of this is done manually. And of course, because this is done manually, it's not really reproducible. So you're relying on one person doing the same thing many times. So that was level 0. Companies and technologists worldwide figured saying, hey, that probably isn't the most ideal way. Let's think of a way that we can actually automate some of these things where Alice or Bob can write a script. And that was really what is called imperative infrastructure as code, where someone would write a deploy script, and the deploy script would interact with an SDK, say of AWS or any other cloud provider. And that SDK would go ahead and create your cloud instances, your organization's infrastructure. What imperative infrastructure as code means is that you are defining literally every single thing that should happen. So to give you an analogy, if you want to ask a robot to get your coffee, you wouldn't say, get my coffee on Monday morning at 9 a.m. You would say, take 3 paces to the right, pick up a jar of milk, pick up some coffee powder, pick up some water, put it in a jar, put it in a blender. You're defining literally every statement. Again, this solved some of the issues of what we had earlier. It's not manual, so you can scale, it's reproducible. But what if something failed? For instance, what if there was no milk in the jar? There was no fallback. Also, this involved a lot of boilerplate code. So debugging became so much more difficult because you literally had to specify every sentence. Also, in something like this, what if 2 people try to access the same resource at the same time? That would lead to race conditions. So imperative infrastructure as code is used, but there are so many other better ways to do it. Level 2 was a slightly better way to do it, which is declarative infrastructure as code. A lot of companies and businesses still use declarative infrastructure as code worldwide, and it is, there are companies built on it, such as HashiCorp and Terraform. How that works essentially is Alice and Bob write an infrastructure.txt file that talks to something that actually provisions your infrastructure using an SDK. So in this case, a service like AWS CloudFormation or Terraform would actually create that cloud infrastructure based on the script that has been written. Now, declarative infrastructure as code is great. A lot of companies use it. And this is how it would look like. So if you're creating, say, something called a VPC or a virtual private cloud, this is the code you would write in your TXT file. You would specify your subnet, you would specify your, what else do we have? Your CIDR blocks, your public subnets, your, your DNS support, your DNS host names. You don't have to worry about all of that, but the people writing those documents actually had to worry about all of this. It was very declarative, so you declare each of these things that you wanted to actually create via CloudFormation or any other service. So infrastructure as code works beautifully. So you write these huge TXT files in either this language called YAML. Bonus points if someone can tell me what YAML actually stands for. And JSON, I'm sure you're familiar with what JSON is. And you upload that to an S3 bucket, somewhere that can be accessed on AWS. CloudFormation reads this file and says, okay, a subnet needs to be created, a DNS has to be assigned, and it goes ahead and creates a virtual private cloud, or it goes ahead and creates like an S3 bucket, based on what you've written. So companies right now are actually built on building their cloud infrastructure using infrastructure as code. But today we're going to talk about something that is slightly futuristic, something that companies are adopting right now, and I think will be the norm in a few years' time. And this is something that I'd like to call infrastructure is code, where you can actually use programming languages to create cloud infrastructure. So far, using either very imperative text or using declarative YAML, for us as programmers might not be the best proposition. So why not actually use programming languages to write code and to write cloud infrastructure? So I'm going to be teaching you about IAC, infrastructure as code, via AWS Cloud Development Kit. So CDK essentially provides another layer of abstraction between your organization's infrastructure and what Alice and Bob are writing. So Alice and Bob, in this case, would actually write a Python program. That Python program will be processed by AWS CDK, which converts that into CloudFormation code, and CloudFormation interacts with the AWS SDK to actually go ahead and create your organization's cloud infrastructure. You might think of, hey, what really is the benefit of something like this? Well, one, for instance, you can actually use coding constructs while doing this. So you can write, if-else statements and for loops and have objects and inheritance, which makes building your cloud infrastructure much more cleaner and so much easier. Second, I'm guessing most of us here are Python programmers. So that level of actually getting from a programming language and building apps to building cloud infrastructure, the learning curve isn't as steep. The onboarding is super easy because, hey, you already know Python programming. And also, you can do all of this in your IDE itself. So you're not actually doing it by hand. And of course, since it's code, you can have version control. You can share it among teams. It is artifacts that can live in your company. So even if someone moves out, you still have that. And there's so many benefits to actually doing it. So CDK is supported in TypeScript, Java, JavaScript, C#, and of course, Python. And today, of course, I will be talking to you about how to use CDK with Python. So here's how it essentially looks. Say I've written a small Python program, which is just a simple hello world program. You would write a cdk app.py or a cdk app.js or whatever, where you're actually using something called a construct. Every CDK program or app uses something called a construct, and I will be explaining what this really is. All right. So one of the big advantages of actually using CDK is this. When you're building something on CloudFormation, using declarative infrastructure as code that I just mentioned, to create something like a virtual private cloud, you would need about 270 lines of YAML code. This is how it would look. Seriously, it's zoomed out because there's so much code. But using something like CDK, you need literally one line of code. And I'm not exaggerating. So all you have to do is something like this, where you say VPC equal to ec2.vpc and just give it a name. So I'm actually creating a virtual private cloud with this one line of code. And if you don't believe me, I'm going to do a demo. So you will see that it actually works. Well, let's actually dive straight into the demo. Now, for the demo, you don't need anything fancy. So you can actually try it at the end of this workshop itself. What we need are, of course, we need Python installed. Well, you need an AWS account and username. This works on a free account as well if you don't have AWS already. You need the AWS CLI announced. You need the AWS CLI installed, not announced. And of course, you need to install the CDK. So you can either do a pip install AWS CDK or an npm install AWS CDK, and that should work. So I'm going to show you a demo now. I've pre-recorded the demo because CloudFormation takes between 3 and 4 minutes to actually provision cloud infrastructure, and it would be awkward as hell if it was just happening and we'd be looking at each other or I'd be looking at the camera. So I've actually recorded this beforehand, and yeah, here goes. All right. So we are going to from the start, and hopefully the text is big enough. So I'm just creating a simple directory now. You know the stuff. Saying, okay, so I just create a folder and I'm going to initialize a CDK project or a CDK app. Now, I can specify the language in which I want my sample app. So in this case, I'm going to specify Python, and this actually generates a sample CDK app in Python. Let me just pause it here. So as you can see, it says all done because it's actually created a CDK sample app that you can get started with really easily, and it's created it in Python. Let's go ahead. Now for CDK to run, I have to set a virtual environment so that it can run. So I'm just going to do a source.virtual environment and activate that, and we're good to go. All right. So as you can see, let me just pause it here. When I created that sample app, essentially CDK has gone ahead and created a folder called, in this case, CDK test, where there is a setup.py as an app.py. It's also created a requirements.txt file, which we will run, and also a bunch of tests, and also a cdk.json file. All right, so I'm going to do a pip install and run requirements.txt so that all the dependencies are actually run. Yeah, there we go. And I am done. Yeah. So I'm just opening this project in Visual Studio Code. And this is the sample project that you actually see. As you can see, the .py file, there's some boilerplate code. You can choose to ignore it for now. Again, since this is a session for beginners, we're going with the simple hello world example for now. Let's look at the folder structure. Yes, so this is a file called cdk test underscore stack py. There's an app.py as well, which is the starting point for your CDK app. So if you look at app.py, it's fairly straightforward. It sets the env here. Let me just do that. Yeah, if you can see, oh, that is a terrible circle. It sets a region. So every AWS code that you execute has to have a region associated with it. Regions are basically, think of it as a bunch of data centers somewhere. So if your customers are, say, in the west of the USA, maybe choose US West. There are regions all over the world. So there's EU West, and there's Japan and India, and so on. Right. So that's the folder structure. And again, app.py is the starting point for your CDK app, but we will be actually creating all the infrastructure in the other Python file that's in the project. And I'll do that now. Yep, region. So like I said, this is a sample app. So there is some boilerplate code, which we will get rid of, and you don't have to worry about it for now if you're a beginner. So let's just remove all of that for now. All right. So for this, I'm going to create a virtual private cloud, our own cloud that we can run our app on. I need to install the CDK construct for a VPC. All right. Now, if you're not familiar with AWS, AWS has the service called EC2, or Elastic Compute Cloud. Via EC2, you can actually provision instances or servers in the cloud. It's one of AWS's most used and one of the oldest services as well. A lot of companies worldwide actually provision EC2 servers in the cloud. And when they do so, they create private clouds for each of these servers so that their data is secure. And that's what we're going to create. Now, AWS has, at last count, more than 200 plus services. So whenever you're using any of these services in your CDK app, you have to add that particular construct to that app. So for instance, if you're storing data using the service called S3, you'll do a pip install AWS-S3. In this example, we are only using EC2. So I'm just going to do a pip install and EC2, and it's installed in my CDK app right now. Now that it's installed, I can, of course, import it into my CDK app. So I imported saying AWS EC2 as EC2. And otherwise, we can do all of that VPC stuff with one line of code. That's exactly what I'm going to do. I'm creating a variable called VPC, and the great thing about CDK, especially if you use an IDE, is that it has autocomplete, and so you can just find all the functions associated with it. So you can just do something like an ec2.vpc and just give it a name, which in this case is my VPC. Just this one single line of code is enough to create a virtual private cloud and give it its own subnets and assign DNS addresses to it. Let's see how that works. So we've written that one line of code. You can run a command called diff to actually see what the difference is between what you started with and what you have now. So as you can see, all of this stuff has been added to your CDK app when we wrote that one line of code. So that one line of code, you're actually getting a VPC, you're getting a subnet, you're getting a route table, and you can see all of this, right? So all of that is happening behind the scenes with that one line of code. CDK diff, again, is the command to actually check what the difference is. Yeah. All of this with just that one line of code. So now that you've done that, you actually know that that line of code is working, you can run something called Cdk synth, which is short for synthesize. What Cdk synth is doing, it's taking that one line of code and converting it to that 270 lines of cloud formation YAML that we spoke about earlier. So it's making your job so much easier. It's actually translation and converting it into declarative infrastructure code, which is basically for cloud formation. So if you put this into a CloudFormation file, your cloud infrastructure will be created. To do so, you need to do something called a bootstrap. And that's what I'm running right now. You can see CDK bootstrap. And let me just explain what that is. Yeah, before I deploy. So for this code to run in CloudFormation and for those resources to be created, this particular file, which is local to your system right now, needs to be in the cloud so that your account can access this and then actually create everything based on the commands in this file. So when you do CDK bootstrap, it essentially stores this YAML template into an S3 bucket so that CloudFormation can access that bucket later and then just create the cloud infrastructure that we have been trying to create. And you do that by just running CDK deploy. So I do a CDK deploy, and it's creating the CloudFormation chain set. Now, this process typically takes 2 to 3 minutes, which was the reason I actually just pre-recorded my demo. So this actually takes a bit. And you can actually see it happen. And you can see the creation in progress. So if you go to your AWS now and you click on CloudFormation, you can actually see this in process. So there you go. These are the different stacks I've created. So you can click on CDK test. And if you click the view nested button, these are all of the events that are happening with that one line of code. And your stack should be ready. As you can see here, it now says create complete, which means all of your cloud infrastructure that you've defined has been created via CDK through CloudFormation. In fact, to check it out, you can actually go to the VPC service and see if it's created. So I just typed out VPC. And you can list out all the VPCs in the region that you've defined. And there you go. We've called it My VPC earlier, and you see it there. So you have a virtual private cloud now that you can run your app in, or you can run servers in. And all of this was possible with just that one line of code. So let's talk a little bit about how this works. So I told you what infrastructure as code is. I told you what infrastructure is code is, and what CDK is about. And I showed you a demo. But how does this really work under the hood? And I think this is so fascinating because I know a lot of people who program JavaScript or Python, do typical front-end, back-end type work. And they had no idea, or they were so surprised to see that they could build cloud infrastructure using the coding language that they use on a day-to-day basis. So let's take a look under the hood and see how CDK constructs actually work. So there are 3 levels to CDK constructs, and we will talk about each of them in detail. At the very bottom is level 1 constructs. These are CloudFormation resources, and these are automatically generated. We'll talk about that in detail. What we used in the demo right now are level 2 constructs. Now, these are AWS constructs such as create a EC2 instance or create a VPC or create an S3 bucket. These are very high-level service-specific constructs, so everything is tied to a service. Oops. And level 3 is your purpose-built constructs. Now, the key word with an L3 or L3 plus construct is they are very opinionated, and I will get to why that's interesting in a bit. So let's talk about each of these in detail. Level 1 constructs are one-to-one mapping from CloudFormation. Remember, I told you CloudFormation needs that YAML code. So these are constructs that map directly to statements you would use in CloudFormation. So for instance, what you can see on the screen is create a new S3 bucket. And you even mention create new S3 bucket, CloudFormation bucket. You give a name, and that is it. So that when you do a CDK synth is mapped to CloudFormation code automatically. So there is a one-to-one mapping between what you're saying in that construct versus what's happening in CloudFormation. Typically, we don't use this as much. You would probably use L2 constructs more often. L2 constructs are what we just used in our demo. So you can see the demo we used there where we said new ec2.vpc and you just gave a name. So this actually gave you a ready to use setup for VPC. You didn't have to mention the subnets or the NAT gateway or DNS addresses or any of that stuff. It basically gave all of that to you. You can choose to provide a region if you want, and it would create the VPC in that region. Everything else, though, is optional, and you have complete control over what you want to specify. And if you don't specify those things, it takes the defaults. So again, onboarding to creating cloud infrastructure for a beginner is so much easier, but for the veteran or for someone building an entire company on CDK, they can get granular options on what customizations they want using CDK. So in this case, when we create the VPC using that one line of code and you do a CDK synth, in the AWS crowd, it creates a VPC, it gives you 2 public subnets, it creates 2 private subnets within different availability zones. I think that's pretty cool. L2 buckets also can be very modular, and also you can choose to define the scope of these 2 buckets. So say you're building a program where there is an S3 bucket and there is a Lambda function. If you're not familiar of what Lambda is, it is a service for serverless compute where you can run event-based code. So say you have a Lambda function to get an object which is stored in S3, and then you put that object in a DynamoDB database. Simple program, and honestly, you can do that with, I don't know, 10 lines of code that you see here. If you were doing this on CloudFormation, you would have to write specific permissions to create policies for Lambda to access the data from the S3 bucket, and another policy for Lambda to put data into that database. And all of this is code that you would have to have written by hand. Again, just makes it way more verbose and prone to error. With CDK and with infrastructure as code, you can essentially just do this. These lines that you see here. So as you can see, it says input bucket, grant read permissions to the Lambda function. So the bucket here gets read permissions or grants read permissions to the Lambda function. That's it. And in the second line, you want to write from Lambda to DynamoDB. So you're just granting write data permissions in the table to the Lambda function. And then Lambda is able to write to DynamoDB. Again, literally with those 2 lines of code, this actually creates policies and roles using something called IAM, or Identity Access and Management, which under the hood sort of manages who has access to what and does all of it in CloudFormation and then it's created. So again, you can create modular services and using these constructs, and also define the scope and permissions using Python code. Okay, there we go. Now, if you're using AWS services, these are the different services available for you in AWS's construct library. And these are L2 services as well. So for instance, if you're doing serverless, you can use Lambda for compute. Lambda is great for event-driven code. So for instance, say you have a program and someone uploads a user image and you want to resize that user image, there's no point running a server 24/7 just for that one operation. Instead, you can do it event-based. So someone uploads an image, you hit a Lambda function, which does that code for you and sends you back the resized image. You can also create an API using Amazon API Gateway, and you can store data in DynamoDB database. You can also use the foundational services of AWS. So, storing data in S3, using queues in SQS or simple queue service, or using notifications in simple notification service, and so on. If you're containers and you do a lot of container wait, why am I, yeah, container orchestration. Oh man, I know that's a tough word. So if you do a lot of that, or if you run applications in containers, you can use Amazon ECS, or you can use Fargate, and you can run them in virtual private clouds as well. And if you want the entire end-to-end to have continuous integration and continuous deployment, you can use code build, code commit, code deploy, and code pipeline with all of these other services I mentioned. And you can use constructs for each of these using CDK. The top level of constructs is L3 constructs. And the key word here is opinionated. Now we realize that starting up an application, or maybe you want to create, especially in the startup world, sitting and writing 829 lines of CloudFormation template, as you can see here, isn't ideal. It takes a lot of time. It could be prone to mistakes. So we basically, based on all our experience creating cloud infrastructure and working with some of the world's largest customers, we give you ready to use constructs that you can use. So for instance, if you want to create a load balancer with where you can deploy containers within a virtual private cloud, we don't want, I mean, you can choose to write your own CDK code or your CloudFormation code, but we give you something called an L3 construct via a library that you can deploy straight away. So you can actually, we have a ready-made construct called application load balanced Fargate service. And it's in a library that you can access. It's completely free to use and it's completely open source. So you can use this and it would create a VPC with subnets, NAT gateways, etc. It would create a load balancer if you have a lot of load coming into your app. It would give you Fargate if you wanted to run containers in a serverless fashion. And it would give you an ECS task definition as well for your compute power. All of this with just few lines of code. So this is an L3 construct where you're using multiple services into this one very opinionated service. I don't know if service is the right word, but this one opinionated app almost that you can straight away use to get started with your business or your application. And this is a completely open ecosystem, for instance. So you can actually check GitHub, and I'm putting the link later on in the deck. You can check GitHub, it's completely open source. CDK is totally open source. And you can also check out CDK patterns, where a lot of commonly used patterns for things including DynamoDB, CloudTrail, CloudFront, CloudWatch, all of that, RDS is all there. So, and there are different permutations and combinations as well. So if you want, for instance, some app that needs like notification and a queuing service, and then writes to something serverless, and then writes to a database, you will probably find it on CDK patterns, and you can just pull it into your app and start using it. How you do that is actually very simple. So in this case, we're using a template again. It's a CloudFormation template. And yeah, so as you can see here, you're importing CloudFormation include here, and you're creating a CloudFormation template that you can reuse within your CDK app. So it's fairly straightforward to use as well. The great thing is you can also write your own CloudFormation templates and upload it to CDK patterns so that other people can use it too. So it's a fairly vibrant community of people across the world who are actually uploading their own patterns for you to use. Lastly, I just want to talk about some of the benefits of CDK. And I know we did touch upon this quite a bit, but I think until you've tried it, you don't realize how flexible and versatile it is. For starters, you can actually use logic that you would in code, like if statements and for loops, when actually defining your cloud infrastructure, something that wasn't really possible before this. And this is very powerful because you can actually code for what cloud infrastructure should be created and when. You can use typical object-oriented techniques to create a model of your system. Again, couldn't do this using YAML or JSON, but now you actually can. Also, from a point of view of organizing your modules in your project, you can actually organize your project into logical modules, which make it so much easier to share between teams, to create version control, to have validations, and to have testing. And of course, if you're a company like, say, a partner or a service company, you can reuse constructs that you have created across different projects. So you don't have to reinvent the wheel at every point of time. So maybe, you're a consulting partner and you run whatever, something like, let's say, like creating virtual events, and you have a CDK pattern that you have created for that. You can actually reuse that for different events and different clients because, well, the infrastructure really stays the same. The good thing also is you can reuse your existing code review workflows as well. Having things like YAML or JSON to create infrastructure changes how your code reviews works. It brings in new processes, but with something like CDK, without adding too many members to your team or adding new specialities, you can manage your existing code reviews as well. And of course, you stay within your IDE. You're actually not going to an AWS console or any other console and actually doing things by hand. You can do all of this within the comfort of your own IDE itself. I'm going to give you some steps for getting started. I'm assuming most people here aren't too familiar with either CDK or IAC. The best way to get started is the first link that you see there, which is cdkworkshop.com. It's a step-by-step how-to on getting started with CDK, and it's in different languages, including Node.js, Python, and Java. So I'm assuming you're going to use the Python one, but do check it out. There's nothing as good as doing something for the first time and by hand, right? As opposed to listening to someone talk about it. So do it hands-on. You can also go to aws.amazon.com/CDK and also the AWS samples GitHub. There are a lot of different samples that you can use. There's a very vibrant community on Gitter. So if you go to gitter.im/AWS/AWS-CDK, there is a community who's contributing very often. So do check out that community and try and be a part of it as well once you get the hang of it. Also check out cdkpatterns.com and cdk8s.io for things especially related to Kubernetes. And also check out awscdk.io for more resources. So I have about, I think that's 8 minutes maybe for questions. So fire away. I'll also be here till the end of this hour, this half an hour. Thank you so much for giving me this opportunity. Please follow me on Twitter. I also do some streaming. I do a lot of talk about emerging tech. I just did season 1 of this thing I'm trying called the Emerging Tech Show. So you can check it out on YouTube. It's where I talk about emerging tech in a very non-serious manner. So do check it out. And yeah, happy to talk to you about cloud, CDK, infrastructure, as code, Python, whatever. Thank you so much for having me. This is Sohan, and see you soon.